Welcome back to a new video. In this video we are going to do exploratory data analysis using Python and its libraries. The dataset that we are going to be analyzing in this video is going to be about movies, and I'm going to leave the datasets link in the description of this video. So you can download the dataset and run the analysis codes that you see in this video. Let's start coding. Now we are in the Kaggle data card of the dataset that we are going to be using in this analysis. And let's quickly take a look at our data. Then I'm going to show you how you can download it, and then we can start our analysis using Python. We are going to do the analysis in Python, but let's take a quick look in here. It says movie dataset for analytics and visualization, and it says movie analytics dataset, genres, ratings, revenue, cast, and more with 1 million rows. Awesome. Okay, let's take a quick look in the data columns. I'm going to select all of those, and here we have movie ID, the primary key, title, genre, release year, release date, country, budget, box office, global box office, numbers, opening day sales, 1 week sales, IMDb rating, and we have Rotten Tomatoes percentage score, number of votes in IMDb, number of votes in Rotten Tomatoes. We have the director and we have the lead actor column. Awesome. Let's analyze this in Python. What I'm going to do is I'm going to add this dataset link from Kaggle in the description of this video. You can directly visit this page, and how we can download this dataset is after signing in or registering, you can just use this download button at the page. If you are working with data or you want to become a data analyst or data scientist, you can just sign in into the Kaggle and visit the platform. It's a nice platform for data, and you can find like data analysis codes, machine learning courses, and stuff like that. Also, there's competitions in this website. You can just sign in, and then after that you can just use this download button at the page for downloading the dataset. Again, one more time, the link of this page is going to be in the description of this video. You can download from here directly. Okay. Now, let's start analyzing this dataset using Python. I'm going to be recording back in a second in my code editor. Okay, here we have VS Code. I'm going to be using VS Code, but you can use any code editor that you want. And in here, you can see that I download the dataset, the CSV file, and put it in the directory that I opened my project on. And you can do the same for applying the codes with me. Also, I have the link here. I got it ready for sharing it with you in the video description. Now, what I'm going to do is, let's say analysis, and I'm going to create an IPMB file which refers to a Jupyter notebook, and we are going to go cell by cell in Jupyter notebook. So, at the start, I'm going to start by selecting my kernel. I'm going to use a Python version of 3.11.4. It doesn't matter if you have something bigger than 3, it's okay. And now let's just do the imports for the start. So what we are going to use on the data analysis side is we are going to use Pandas for sure for analytics and manipulation, and we are going to use Matplotlib for visualization. And we are going to use Seaborn for visualization again, like this. We can import it like this. And also I want to import NumPy. And now we have those ready. And after that we can just use Pandas like using the PD. And we can say Pandas read CSV. And in here what I'm going to do is I'm going to come to here and copy the movies dataset CSV. I will say copy relative path in here, and I'm just going to paste it in here like this. So when I make this run, it's going to give me the dataset, and I'm going to save this to something like data frame. So after that, when I call the data frame, I can reach to this instantly like this. It's stored in the data frame right now. We don't need to read the data again. And let's start by calling dataframe.information like this. And we are going to see like the range index, how many entries we have. We are going to see our data by column wise and their data types. And also we are going to see the memory usage from here. We have 6 floats, 5 integers, and 6 objects in our data. and I'm going to call the data frame.head at the first place. It returns the first 5 rows of the dataset. If you call tail, it's going to return the last 5, and also if you just say head, you are going to see 5, but you can specify this number, like I'm going to say 3, and it's going to return me the first 3 rows. So the default value is 5. Okay, let's talk about the dataset. We have movie ID like primary key, we have titles of the movies, we have genre, we have release year, we have release date, we have country, we have the budget, and we have the box office numbers, we have the global box office numbers. This one was US. We have opening day of sales. In here we have 1 week sales, we have the ratings from the IMDb, we have the Rotten Tomatoes score, we have number of votes, IMDb number of votes, Rotten Tomatoes, and we have director with the lead actor. Okay, awesome. Let's start by getting the row and column count. So what I'm going to say, data frame.shape, we have the row count from here, also the column count, but we can reach the same information like this. Okay, also we can call data frame data types, and data types actually like this. This is going to return column-wise data types. Okay, let's get the descriptive statistics of numerical columns at the first place. I will say describe, and we are going to see that actually I'm only curious about the ratings, so I'm going to go to there. These are scientific numbers. If you want to work with those, you can just take that column and then turn it into a different data format for seeing it fully, but I just want to check the ratings for the IMDb and Rotten Tomatoes. So let me check which one was the average standard deviation. So our average here is 6.4 and the standard deviation is 1.4. Okay, and on the Rotten Tomatoes it scales 1 to 100. We have the average of 64 and we have the standard deviation of 17. And okay, looks great. Let's continue by checking the missing and duplicated values. So what I'm going to do is I will say data frame is an A, and I will use that sum. So in this way I'm going to have like column-wise information on if we have any missing data or not. But if I say sum again, we are going to see the total NA count in our data, and it's 0. We don't have any missing values. Okay, let's check for the duplicates. In duplicates, we can call the function duplicated, and it returns true or false row-wise. And if we just use sum after that, we are going to see the total count. And in here we can see that we don't have any duplicated values. Awesome. Okay, now let's create histograms and see the distributions of the numerical columns. For that, what I'm going to do is, for seeing the columns, I will say dataframe.columns, and in here I'm going to create a list like numeric columns, and it's going to be, let's go one by one. I'm going to take budget USD, and I'm going to take US box office USD. I'm going to take global box office USD, and I'm going to take like opening day sales like this, and then I'm going to take 1 week sales like this, and I will take IMDb rating from here, and next I'm going to take Rotten Tomatoes score, and I'm going to take number of votes IMDb, and lastly I'm going to take number of votes Rotten Tomatoes like this. Okay, so after running this, what I'm going to do is I will say for column in numeric columns, so I'm going to iterate over it. Like, let me just print the column. You are going to see we iterate over the numeric columns list in here. I will say, let's use Seaborn. I will say Seaborn histogram plot. I will pass data frame, the column, and let's set the bins like 50, and also I'm going to set this to true, the KD, and I will say title. Title is going to be distribution, And since I use f string, I can directly pass something dynamical in here like column, and I will say plt.show. Also, before running this, I don't want to see any type of errors in my code, so I will say import warnings, and I will say warnings, filter warnings, and I will say ignore, because I don't want to see any future depreciation warnings or anything like that. So let's make this run. I'm going to make the cell run right now, and we are going to see our plots are going to come in our sequence one by one. So let's take a look on them one by one in here. Okay, so on the budget side, we can see that we have more values on the lower end, like these are scientific numbers, but at the starting points, we have more movies, which we can expect. And with the increasing budget, we can see that we have less movies with more budget. So most of the movies are on a low budget. And I think we are going to see a same situation for the other ones for the box office. Okay, I'm just going to skip those because they are all similar, because we have more in the lower end, which we can expect. And let's see the distribution side. In the IMDb rating distributions, we can see that at the values closer to 10, we have more values, and at the values closer to 0, we have like less movies. So we can say that at the higher end of the scale, we have more movies compared to the lower end. And also at the middle side, we can see it's well distributed. And let's also see the Rotten Tomatoes score. Yeah, here we have a lot of movies at the higher end side, and also we can see we have a well distributed data in here. And for the number of votes, we can directly skip. These are like not really meaning something, and we can continue. Let's take a look at the distribution of categorical features. So for that, I will say data frame, columns again, and in here I'm going to create something like categorical columns. And it's going to be, let's start taking one by one. We will take genre. I'm not going to take stuff like title, it's not necessary. I will take genre, and I will take country like this. I can like to copy this. And next, let's take director and lead actor. So I can say director and lead actor. And also I'm going to create a for loop in here again. I will say for column, in categorical columns, data frame, column, value counts. I will say head 20, and I will say plot, and I'm going to create bar plots for seeing the distributions. And also I will say title, we are going to be showing the top 20 column counts like this, and we can pass plt.show. So we are going to have something like this. So let's talk about it one by one again. At the top 20 genre counts, we can see that drama is the clear winner and sci-fi is the least. And the top list goes like drama, comedy, action, and it goes thriller, romance, horror, documentary, and sci-fi. And we can see we have a big gap between the biggest value and the smallest value in our distribution. Okay, let's see the top 20 country counts. Here we have the most movies in the USA side, and it goes like UK, India, Canada, China, Australia, France, Japan, Germany, and South Korea. Okay, let's see the top 20 director counts. So in here we have, let's start with Tara Underwood, and it ends with Gary Simmons. And we can see the directors like this. Okay, let's also check the lead actor counts. Here, Jeffrey Smith is the most occurring value, and Ashley Pina is the least, based on the top 20. Like again, in here, we are just looking for the top 20. I'm saying like lists for the Gary Simmons and also Ashley Pina, but it's only for the top 20 list. Like they are going to be at the 20 for the full list of actors and also the directors. It's just like our sample in here. Okay, let's continue with relationships. So I'm considering the relationship between the box office and budget. So for that we will say Seaborn, scatter plot, data frame, and X is going to be budget USD. And let me call the columns again because I'm not sure about the column names. So here, okay, I can see those. Now I can set that Y like global box office USD. Yeah, correct. And next up, I'm going to set the alpha parameter like 0.3. And next up, what I'm going to do is I will say title, and it's going to be budget versus global box office. And I'm going to add the X scale, logarithmic, and Y scale like this, and I will use plt.show at the end. So we have here our plot, and it seems like they're increasing together. Like when the box office USD increases, budget increases, and when budget decreases, box office USD decreases. Now let's analyze the ratings. So I will say Seaborn, scatter plot, data frame, and X IMDb rating. It was like this. Let me quickly check again. Yes, correct. And Y is going to be Rotten Tomatoes, like this score. Yeah, here it is. And I'm going to set the alpha at 0.3 again, and this time I will say title IMDb versus Rotten Tomatoes ratings, and I will use plt.show. Actually, I think I have a typo in the column names. Yeah, so I got this missing here, so this time it needs to work. Yeah, correct. It seems they are correlated too, but think like in some cases we have the IMDb rating of 10 but Rotten Tomatoes score of 60, and in some cases we have like IMDb rating of 4 but on the Rotten Tomatoes score we have like 80 on that values. Okay, now let's do some group by analysis. For that I will say, let me think of the columns. Let's group our data like for each genre and release year and see the average ratings and revenues. For that we will say genre, year stats, and it's going to be data frame group by. We are going to group by two things, so group by is going to take a list in here. I will say genre and release year. Actually, let me check if I have a typo in here. Release like this. Okay. And I will say aggregation. Now what we are going to do is we are going to go one by one on columns like global, and I will say box office USD, and I will say mean. Next up we have budget USD, so I will say budget USD mean, IMDb rating mean, and also since we are going all averages, Rotten Tomatoes score mean like this. So let me show you the result of this. Like I will call genre year stats. Here we have the index of genre and we have release year and the averages. So okay, what I'm going to do next is I will say add reset index in here. So we are going to have genre as column right now when I call this instead of index. Here, as you can see, we have the genre column. And now I'm going to create a line plot from this. Like I will say Seaborn, line plot. I will say data is going to be genre year stats. And X is going to be the release year. And Y is going to be global box office USD. And I'm going to add the hue of genre. And next up, I'm going to say title, it's the average global box office by genre over years. Also, I will say plt.show. And we have a typo in the column names, I guess. Let me quickly check. Yeah, I need to use capital letters on the global box office side, like I will say USD like this. Okay, awesome. Also, we can make the just figure size, like let's say plt figure. Let's make it bigger. So I will say figure size and 63. Actually, let's use like 26 to 13. Okay, maybe go with something like 14 to 8. Okay, it's better. Now, what else we can do is we can say 12 to 6. Here it is. Okay, 15 to 10 is going to be the best, I guess. Yeah, here. Here is our line chart by genre. And we can just filter by genre and see the results. Like, let's say we want to only check the values of action. So what we can do is we can just say after this that query, and we can pass like genre equals to action like this. And now we are going to see that we have the distribution of genre, or we can do this with like 2 columns. We can easily change the query in here for that. Okay, let's do a final analysis. Let's do like top lead actors by average IMDb rating. So we can do something like top actors, and it's going to be data frame group by, we are going to group our data by lead actor, and I will say IMDb rating dot mean after that. So we are going to have something like this in here. And what I'm going to do next in here is I will say sort values, and I will say ascending equals to false. And next up I'm going to say head and 10. So we are going to have the top 10 in here like this. And I will say like top actors dot plot, and I will say kind equals to bar, and I will use plt dot title. Let's say top 10 actors by average IMDb rating, and we can pass plt dot show. Here is our result. And let's say that you just want to change this number, like let's say you want 50 actors instead of 10. So you can go in here and say 50, and you are going to make this run again. Let's change the title to, I'm going to make it run, and we are going to see 50 like this. Again, you can make this plot bigger using plt figure and passing figure size equals to, let's say 15 to 8. So we are going to have a bigger plot like this. Okay, that was it for the analysis, and let's get to the outro. Thanks for watching this video on Exploratory Data Analysis. I have a playlist named Data Analysis Tutorials where I have more than 40 videos just like this one. You can check that playlist from the cards of this video or from the links in the description. Also, I'm sharing a new data science video every week on my channel. You can subscribe for more videos like this. Have a great day.